Hello, it's Tommy, and I'm going to go over my midterm interview. So the first question is design a data type that can do these three things, and I've defined these three functionalities in terms of three methods: add review, search by date range, and search by name. So I've decided to call this data type reviewer, and I'm going to go over three approaches with n and analyze them based on n, the total number of reviews, and m, the total number of reviews by the date range query. I'm going to note that n and m will be synonymous because in the worst case, you'll have to return all n reviews by the date range query. So for my analysis, for the worst case analysis, n and m will be equal. So the first implementation is an array list reviewer, so it contains a array list of review objects defined as such. So the add review would simply add review at the end of the array list, and this would be using the array list adds method, which would execute in theta of 1, assuming that no resizing occurs. So both of the search method would have to loop through the array list, and assuming that they would be returning everything. The query would return everything in the worst case. That would just be copying everything over to a result list. So that would mean m is equal to n, and the worst case would just be the n, which is the amount of the total amount of reviews. The next implementation is a map reviewer. So this would be using a hash map that maps strings, which is the usernames, and list of reviews, a list of review objects that the person with this username has left. So the add review here would add a new entry into the map if the user has not left any reviews before. If the user is already a key in the hash map, then it will add a review in the corresponding review list, and that will be theta of 1, assuming no resizing, because adding to a hash map takes theta of 1, and adding to the end of a list also takes theta of 1. So I mean an array list would take theta of 1, assuming no resizing happens. So the next method is search by name, which would return the list that any given name is mapped to. So that would just be one line of using the maps get method, which would be theta of 1. The next search method would be searching by date range, and this would iterate through every user in the key set of the map, and for each user, it will iterate through all the reviews that the user has left, so the list of reviews, and copying the reviews within the date range to a new list to be returned. So in the worst case, it will have to examine and copy over n reviews to be returned. So the overall worst case runtime will be theta of n. So the next implementation is a tree set reviewer. So this implementation contains a tree set of review objects sort of based on dates, so what that means is a later date will come later in the set. So the add review would add a new review into the tree set, and as we know, the insertion method for a tree set would always take theta of log n time to run. So the add review would just be theta of log n in the worst case. So the searching by name just iterates through the tree set and copies reviews with the same name as the search key to the result list. Search by date range does the same thing, except it adds all the reviews in the date range, so greater than start, less than end, to the result list. So since in the worst case both of these are just copying everything over to a result list, you would expect theta of n in the worst case. So the next interview question is we have to design a data type that does these three things, and again I have summarized the methods here. Add post, which is just add a post to this data type. Undo, which is undo the last post by a given username, and all post, which is return all the posts by a given username. So I've decided to call this data type postboard, and again I'm going to analyze each method of each approach with the worst case asymptotic analysis with these fit2 variables. So the first implementation I did was an array list postboard, so it contains an array list of post objects defined like this, and the add post would just add a new post at the end of the array list. So as we talked before, this would just be theta of 1, assuming no resizing of the array list happens, and undo of a username would iterate from the back of the array list. So that would be the most recent posts, and it would find the first occurrence of the post. It would iterate towards the front, and it would find the first occurrence of the post posted by this given username, and would remove that post. So this would be theta of n in the worst case due to having to iterate through all posts, and also having to shift everything over based on how the array lists remove method is implemented. So the all posts username method would iterate through from the front of the array list and copy all occurrence of the post by a given user and copy the results to a result list. So in the worst case, you would have to copy every single element over and effectively create a new array list to be returned. And this would be theta of n. The second implementation is going to involve a hash map that maps string usernames as strings to link decks of posts, which are the collections of all posts that a certain user has posted. So the add post method would just add a post to the back of this user's deck of posts. So this would run in theta of 1. In the worst case, assuming that no resizing of the hash table happens. And this is because both the get method of the hash map and the add last method of the link deck take theta of 1. The undo method of the deck, so this method will also get the deck map to the given user, and it would perform add last, which would also be theta of 1, because you would need to call the get method and the remove last method. And also assuming that no resizing of the hash table occurs. So the all post method, this would simply be implemented by calling get on the deck, getting the deck map to the given user, and basically turning that deck into a list to be returned. So you would have to iterate through the length of the deck and copy everything over to a list. So assuming that k is the length of the deck, so k is how many posts the user has posted. The runtime in looping through it would be worst case of a theta of k, but since we're to assume that any other data besides the asymptotic variable is constant, the worst case runtime here would be theta of 1. Okay, so in the third implementation, we'll be using a hash set, and so this hash set post board will contain a hash set of post objects, and also a post is considered greater if its state is more recent. Now, add posts would simply add to the hash set with theta of n worst case runtime, since hash set's add method is always going to take constant time, assuming that no hash table resizing occurs. The undo method would iterate through the entire hash set with a temporary post variable intended to track the most recent post by the given username. So after the loop, whatever is stored in the temporary post object will be the most recent post by the user that we want, and this post will be removed from the hash set. So in the worst case, this would be theta of n, since we are iterating through with n posts, and removing simply just takes theta of 1. So the all post method would also iterate through the hash set, and it would add every single post by the specified user into a temporary array list. So this step would take theta of n in the worst case due to looping through all the n number of posts. Then this array list will be sorted by date using timsort, and this would take, and timsort's worst case runtime is theta of n log n. So finally, the array list would be in increasing order of date, so it would be in the order of which the posts are added, and this would be returned. So since this method consists of a theta of n step and a theta of n log n step, the overall worst case runtime would be theta of n log n. Okay, so this next question, another data type with the 3 methods: cast vote of a candidate of any type, count all the votes of a candidate, and get the winner. So this type of data type, I decided to call it an election, and I'm going to go over each method and give the worst case asymptotic analysis. So the first implementation is hash map election. So this contains a hash map of all the candidates as strings mapped to their vote counts as integers. So cast vote method would just it would take a string, which is the candidate's name, and it would increment the candidate. It would get that candidate's name in the map, and it would get the integer value that is mapped to, and incremented by 1. So this would be theta of 1 in the worst case, because hash map's get method is always theta of 1. So the count method would just do the same thing above, but it would just, instead of incrementing it, it would just return it. So it would just be something like that, and that would also be theta of 1 in the worst case for the same reason. And get winner will just, so how this works is it establishes a temp variable intended to store the candidate with the maximum number of votes, and it constantly updates this maximum by looping through the key set of the map and checking the votes of each candidate. Like if the next candidate is greater than the current maximum, then you would just update the current maximum, and this pass through the key set will result in a theta of m, worst case, where m is the amount of candidates. So the next implementation is within an array list. So here I decided to design a class called a candidate, which was just name and votes. And yeah, it contains an array list of these objects, and it casts votes of a candidate of a variable of type candidate will perform sequential search on the array list until it finds the candidate A, and it will increment its vote field by 1. So that would be theta of m, because you will have to again loop through m candidates, which is the total number of candidates, and count vote will actually be the same. It would do the same thing above, but just return the votes instead of incrementing it. So that's also theta of m. And get winner would loop through the array list, and it's kind of like the last implementation where it uses a temp candidate variable to track the candidate with a maximum number of votes, and it kind of updates the maximum as you loop through it. So it returns that maximum candidate in the end. And since this requires one pass through m candidates, the runtime would be theta of m in the worst case. Okay, so for the next implementation, we'll be using an LRB tree. And the nodes of this LRB tree are going to be defined by a class that has a candidate object, a reference to the left child and a reference to the right child. And candidates are going to be considered greater if their number of votes is greater. So that's how you determine whether to go left or right. And for cast vote and count vote, actually, for these both of these two methods, we just have to find the node. And for cast vote, we're just incrementing it by 1. And for count vote, we're just returning the current number of votes. So to find a node in a tree, the worst case would be that the tree is on the node is on the very last level of the tree. So you will have to traverse through the entire height of the tree. So in this case, if we have m candidates, the height of the tree will be log of m. So the worst case runtime for both of these methods will actually turn out to be theta of log m, because the LRB tree is always going to have its height to be logarithmic with respect to the number of nodes that it has. And the get winner method will also do something similar. It will traverse down the LRB tree by always going to the right, because whenever you go to the right, that means you're going to reach a new large candidate node with a higher number of votes. So once you can no longer go right, that means that you're going to reach your winner, and that object would simply be returned. So in this case, since you're also in the worst case, you would also be traversing to the very bottom. The worst case runtime would also be log of m. And I believe that's everything. Thank you for listening.